Right, our third video, revising through paper 2, and we're going to look at our trig identities and how we can use them to prove that your left-hand side is equal to your right-hand side. So people, very, very important, you need to know these two trig, it's only two, my darlings, trig identities. So tan theta, you must know that tan theta is equal to sine theta over cos theta. Just another thing that you can just perhaps remember is that tan square theta can also be sine square theta over cos square theta. Okay, so the squaring of it also still makes tan theta equal to sine theta over cos theta, even though it's squared. And the next one is sine square theta plus cos square theta is equal to a beautiful round number of 1. Please remember that. You can also rewrite it in the following two ways. If you want to get cos square theta alone, you take the sine square theta over and you subtract it from both sides. Same with sine square theta. If you want that alone, you take the cos square theta and you throw that over and you subtract it on the other side. So please remember that there's a few ways of writing it, but please, you need to know these. All right, now let's quickly get to proving using the trig identities. So they will say to you, prove the following. 1 over cos square theta minus 1, that is equal to tan square theta. People, very, very, very important. You have to do left-hand side and your right-hand side. Please, 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 please. Your right-hand side, normally you don't do anything to that side. You're going to wiggle and wriggle with your left-hand side, and hopefully it gives you equal to the right-hand side. Okay, so let's write up our left-hand side. It's 1 over cos square theta minus, and immediately when I see fractions, let me make this one also so long a fraction as 1 over 1. I force it into a fraction by putting it over 1. And now we're going to say, the only thing I can do from here is I need to get a common LCD. So I want to put them both over cos square theta. Now with this side, I didn't do anything. So it's going to stay a 1 at the top and then a minus, and I changed that 1 to a cos square theta. So I times it with cos square theta, and this is where your fractions there that we all love so much and that we didn't listen in grade 7. What you do at the bottom, you do at the top, and at the top then 1 times cos square theta is just cos square theta. Okay, let me just delete the extras there, the explanation, and now we can continue. And 1 minus cos square theta. Let's go have a look. 1 minus cos square theta. Aha, yeah, I've got it. That 1 minus cos square theta is equal to sine square theta. So sine square theta at the top over cos square theta, and remember, sine over cos, even if it's squared, can become a tan square theta. And here I've got my left-hand side equal to my right-hand side, thus left-hand side is equal to right-hand side. So people, please, whenever they say prove that this is equal to that, you cannot go and write the whole thing out as if it is true, as if they are equal to each other. You need to have like sort of a division line, and you do your left hand side, you tweak and weak it, and you make it until it gets to the right hand side to prove that they are the same. So please, with these people, you're going to lose marks if you're just going to go and write over that again. And even if you start tweaking here, you cannot equal it to each other. That's something we need to prove. Okay. Let's look at number B. All right. So now if you have an overall look, let's first go write up our left-hand side, because again, it's proof that tan theta plus cos theta over 1 square theta, 1 plus, blah, 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 you can read. Okay. So, but we need to create a left-hand side and a right-hand side. Our right-hand side is sort of simplified. it is just one term. So we're just going to leave it. Maybe sometimes you tweak at it, but most of the time you just work at it on your left-hand side. Okay, so tan theta. So can you see here we've got tan, cos, sine. So now we've got one that's sort of out of sorts here, which is the tan theta. Let's change the tan theta into sine theta over cos theta, just so that we are working with sine and coses. Okay, and then the other side, I'm just going to write it over again. Okay, and now we need to bring it together with a common LCD, okay, because we want to make it one term. So we want to change it so that we've got a cos theta times by a 1 sine theta. And now you need to go ask yourself, what did I do to this term to change the denominator to cos theta times 1 plus sine theta? We times it with 1 plus sine theta. So what I do at the bottom, I need to do on top. So this sine theta over here needs to be multiplied with this part of my denominator, 1 plus sine theta. Plus, what did I do to this denominator to make it the whole of this denominator? Which one did I multiply it with? Cos theta. So I need to cos theta times by cos theta. And can you see that I can immediately go and write cos square theta? Okay, so just the same as your fractions would work. Please have a look that you can do that. Very, very important. So you find a common LCD and then you say to yourself, what did I do to the one what did I do to the one fraction at the bottom? What I do at the bottom, I have to do on top. Okay, if you don't want to bring it together all of a sudden, you can keep it as two separate fractions and then add to give you, the one term at the top like that. Okay, so now we want to simplify this. Let's multiply in over here. So sine theta times 1 is just sine theta. Plus sine theta times sine theta is sine square theta plus cos square theta over cos theta times 1 plus sine theta. And now this is a time where you sort of have to look back and say, what? Is there maybe a trig identity that is popping up? Because I've simplified as far as I can, and now I'm sort of out of bounds as to what to do. Then, if you look at your trig identities here at the top, remember that sine square theta plus cos square theta is 1. And I've got it over there. So you need to practice these so much that you can start realizing, but look there, I've got a sine square theta and a cos square theta added together, which will give me 1 if I simplify that. So then I've got sine theta plus 1 over cos theta times by the 1 plus sine theta. And isn't this sine theta plus 1 the same as 1 plus sine theta? Yeah, so you can actually go and rewrite it if you wanted to. Otherwise, you could have just deleted it out. Okay, but let me just write it down. Then I bundle this together as that, and then I'm going to delete that 1 plus sine theta over 1 plus sine theta. And I've got a cos theta left. Yes, and hopefully you check your right-hand side and you don't go and write it as cos theta, but 1 over cos theta. Left-hand side. Let me just make it a bit smaller. Thus, left-hand side is equal to right-hand side, and I have proved that they are equal. Yay! Okay. People, I hope it helped. These are just examples that I'm working through, but hopefully here and there you get reminded of something. Okay, thank you for watching. Have a great day. Cheers.